Brian Phillips with PRM. This is an AOP system, PRM rental unit, rental number 5614. You've seen right there. It has a full telemetry control, the main ozone HMI screen. There are multiple, maybe I've got the camera turned the wrong way, that's better. It said full telemetry control, Siemens HMI. We got, that's the ozone screen. And there, you can see we got our ozone generator. It's running right now. Sparge compressor for additional air. It's also operational. Hour meters underneath each unit. Hydrogen peroxide pump select. So if we want hydrogen peroxide to also operate during ozone generation, click that button. It'll turn green. If I can get my finger on it while I'm, there it is. You can see we see our ozone producing lights. I mean, we are producing ozone. That's a return back from the ozone generator. We're going to turn that off for a second while I finish talking. Same thing, additional sparge air. Compressor pressure. That's feeding the oxygen generator and our motive air for our inductor. So we have a minimum of 90 psi that we want. So that's a low pressure alarm. And we have 150 as our high pressure. The compressor is a 120 psi unit, 105 to 120, but the oxygen generator is max 150, so that's why we got that in case we get a run-on of the compressor. Here we have a low flow alarm, which comes from the Assert oxygen pump, oxygen flow meter. Now that's in liters per minute. And here on another screen here, I do have my status page. It's hard to do this when here we go, when I'm trying to talk. So the air is actually flow in CFM, cubic feet per hour instead of liters per minute. So it's a multiplier 2.12. That's why this number is a little bit more than double the number up here. We're going to go back here. I don't know, while we're at the status page, there's our sparge pressure that we're introducing also into the injection header. Sparge temp after the heat exchanger. H2O2 level tank. That's done with an ultrasonic level transmitter, which is just sitting right there, which will be in the back room. Compressor pressure maintained between 105, but it turns back on at 105. That's why it just dropped, but you see it's coming right back up. Turns off at 120. Here we go, there's our ozone flow and control room temp. So there is a very large 4-ton air conditioned unit. This is just the air handler, and the compressor is outside for that with a disconnect. So we should stay nice and cold inside of this room. Now here's the position of all our different actuated valves in percentage, all of them. That's our sparge set point and our sparge pressure. So right this minute, it's doing all that it can do. That's why it's 11 psi. We got it set for 15. The bleed valve is fully closed, so we are pushing all the air down the well right now, which is what we want. So we're going to get back here, go back to the control screen here, if I can. So back to our ozone screen. Ambient ozone alarm, which we have right there. It's scaled out 0 to 2.0 ppm. It is set at 0.1 ppm as an alarm state. So there it is, actually. That's saying that there's an alarm right there. And that's showing what the actual number is. You'll be able to see remotely. And you got your room oxygen level, which as you can see is showing 20.48. And that is the sensor there, no display, but it's scaled 0 to 25%. And we alarm at 23% in the room, which if it zooms in, there are the hard set alarm set points built into the PLC. So these are non-adjustable, and these are for the safety of everyone inside the equipment. Let's see, we've got, these are control solenoids inside of the ozone generator that we are controlling. Both of those have to be green to be flowing oxygen or ozone, or both. Here's a list of alarms inside the ozone generator. As you can see, low feed pressure, low gas pressure, feed gas pressure high, outlet low gas pressure. These all are just part of the logic. We got phase loss alarm. If we lose a leg coming into the system, this device right here in the control panel will start flashing red colors, and you look at the diagram there and it tells you what the alarm actually is. You get to set it at the proper voltage. The other numbers will stay the same. This is a 480 volt system. So here we go. We got our feed pressure coming from our oxygen tank, our ozone gas outlet, and our Venturi inlet, which I think is right before the ozone generator. Room oxygen level there, we talked about those. And purge cycle, that's when the unit is in, when we first turn the unit off, which I'm going to do. We'll do that real quick. We're going to stop it. Everything stops. Our green light's turned off for our solenoids inside of the ozone generator. Anytime we restart this ozone generator, we go through a purge cycle, 180 seconds. So we will turn on the ozone generator back into auto. A little time delay. You're going to notice here in a second that we'll get one green solenoid on. Then we went into purge while I was gone. So you can see the purge cycle has started. That is flashing while we're purging. We are not generating ozone right now. As you can see, the green light is not lit up on the auto, so we're not generating ozone yet. We're also not sparging. As you see, the sparge light's not lit up. It is waiting for producing ozone right here. So we're waiting for that. So we got to finish our 180 second 3-minute purge cycle. So we're down to a little over 2 minutes. This is exactly what we want to see. Is while we're purging, we want to see 10 PSI right here, which is adjusted and always set and shouldn't have to mess with it. Is this ball valve right here. So when you get it, when it shows up, it will be set. It should run at 10 PSI. If your pressure is excessively low or high, like 8, if it's at 8, then you need to barely close the valve, just a tiny smidgen, and it should go up slowly, incrementally. And it would slowly come up, but we like to see the somewhere between 9.5 and 10.5 right there on our O3 gas generator outlet. We have to keep that backed up with that valve. So you see we've got a little over a minute left. While it's doing that, I'm going to, so we went over the status page already. Oh, let's see, we're going to go back a page. We're going to go to the injection timer screen. So this is sparge zones 1 through 6. You put how many minutes you want each individual leg. When that leg starts to time down, you'll have how much time is left on that leg. These legs do not stop unless you hit this stop button. And they just recycle over and over. Then you have your H2O2 zones. So you set them for how long you want. Now they will correspondingly stay in track with sparge 1 zones. But you do not set the H2O2 longer than the sparge time. So maybe if you're wanting 1 hour of sparge, maybe do 55 minutes of H2O2 or less. And then they will count down, but they will stay in sync in case you So you'll be sparging and H2O2 injecting at the same time. And here is a list of the valve positions for your 6 legs. Tells you if they're open or closed. And if both lights are off, like if it's gray, the valve is in the middle, it's probably moving from one position to the other. Ozone power level, 35%. It's probably going to be fine for this site. And H2O2 pump speed, we want to keep it pretty much above 50%, maybe a little more, because the hydrogen peroxide likes to degas, and the pump will lose prime if you're not careful. And there's total injection time for as the legs have been cycling. So we're going to go back, as I have heard the system start back up. Sparge is back on, ozone producing. We got a green light there, all is good. We're at 10.9. That number is not quite as important now since we're sparging. I would expect that number when you're sparging to be higher than 10. So don't worry if it gets higher than 10 while it's sparging, because it's going to go higher because we're pushing more air out the same discharge pipe. Injection, we've got status, we've got alarm screens. So here is H2O tank level warning. So you'll set these based off of where your sensor is, how big your tank is. So if you want the tank to alarm at 50% full, it'll alarm at 50%, send you an email. And shut down, it'll shut the pump down if it drops below 95% full here. So those are just user selectable, and they would have to be reset by the button, by the alarm button. But since the sensor's up against the wall right this second, I'm going to pick it up here. I'm going to go to a status page, and as you can see, H2O tank level. Sorry about the zoom in. I am moving the sensor further away from its point. I'm moving it further away. So that means the tank's more and more empty. So this sensor goes at the top of the tank, aiming down into the tank. So when the liquid is up closer to the tank, to the sensor, it'll be closer to 100%. As the liquid level drops and the distance is further, the percentage goes down. As you can see, I'm aiming it at the floor. Look, I'm standing up. I'm aiming it all the way at the floor, and we're down at 26%. So those, depending on the tank size, those will have to be set by the end user. We have sparge temp, which is after the heat exchanger. Oh, we talked about that already. We're going to go back here. I remember where we were now. We were back here at alarm screen. Sparge pressure. Oh, we don't want that at 100. We might want that at like 25. There's going to be a relief valve also put in. It's not in right this yet. And 5 psi, so it'll just send you an alarm if you're not if you're not getting enough pressure. Maybe a compressor has faulted, but it'll switch every hour. It switches to another compressor. So H2O2 room temp. If it drops below 40 degrees in here, we'll get a alarm high temp set point. 110, perfect. Control room, 40 degrees and 110. Motor overload fault. If any of the overloads on the contactors have tripped, motor faults, you'll get a light up there. And hydrogen peroxide room temp fan set point. So it's set to turn on at 72 degrees, which is a little low, so we'll turn that. We'll probably set it at 80. And every 2-degree differential on the on-off. So it actually doesn't come on until 82 degrees, and then it turns off at 80 is what it works. But also I think every hour the fan turns on for 5 minutes in the room. Part of the programming. Sorry about that. Here we go. Manual screen. Manual screen, strictly to press buttons to make things happen without any alarms. This is only used if you know what you were doing. Maybe when the technician is out there, we'll do it for checking rotation or so forth, but not much else to do with this. And alarm screen, ozone injection totals, just tells you how long each individual zone has been on. So you see we've been running these 2 zones, and we've done some downloads, so that's why they're not added up. And you see we've been doing these 2 zones, and all these are zeros. We just hadn't been running them recently. We do not do an exit runtime that gets us out of the main program. You can go back into it if you mess up, but I don't think there's any reason for me to show you that now. Let's see if I can stay in the... I'm gonna stop it. Sorry for the blurriness. I don't know what's doing the blurriness right now. Maybe it's a fogged up lens. No, or it's just a clinky. There's no telling how long he's been standing there. Why is it so blurry looking? There it goes. Battery backup for the PLC. Some temp controller, temperature pumps there. There's the room temp sensor. Other sensors going to the other room. There's an audible alarm, visual alarm for faults in the room. Breaker panel with all the just all 240 volt and 120 volt circuits. As you can see, this thing has a high leg, and the only legs 1 and 2 can have 120 volt circuits. Very, very important. It's a Spartan ozone generator. We have oxygen in, ozone out, ozone pressure, oxygen flow. Got a quick little calculation right there, because that flow meter and that flow meter don't show the same thing, because there's pressure in this flow meter. Roughly 20 psi, so there's a compensation. About 1.5 is the service factor to come up with that. Cooling fan, oxygen tank, regulator, will be set somewhere right around 21 psi. 26, we shut down. This is a bleed valve. As you can see, we've got everything written. Normally closed, this valve should be closed all the time. This valve here should be open all the time. This is tank pressure. It's going to probably be somewhere around 70 psi most of the time. It's a little low right there. Let's see. It's moving some oxygen, evidently. Cycling. We've got compressor pressure. We've got the sparge compressors. They are running right now. We are going to have a relief valve right here that's just not here right now. There's the transformer for all the 240 volt equipment in the room. I think we talked about air conditioning earlier. These are the 6 air/ozone injection legs, 4 to 20 controlled valves. Bottom legs are the hydrogen peroxide injection. Air dryer for the only for the air, for the sparge air, for the volume is so much higher. All these valves here, as I say, normally open. But right now I'm not hooked up to them, so I've got them closed. All those valves should be open if you're using the legs. This is our additional sparge inlet flow. It's labeled main sparge valve. You see there we're moving like 5 CFM on that leg of just additional sparge air. So that only opens up when the sparge compressors are on. We've got air receiver tank. Sorry about so close to it, but air receiver tank goes through 2 filters, goes through the dryer. Then it comes up to this pretty important little setup here. So this regulator here should always be set at 100 psi. 100 psi. That is our motive air, as it says it right there. And it's going to be somewhere, the top of the ball should be at about 15. When it's set at 100, it's pretty much always going to be that. So means we're moving about 15, but we're at 100 PSI inside of this regulator, so you got to multiply 3 almost. So we're doing about 50 liters per minute of additional motive air coming through. This valve here is our motive air valve. It's 100% open. Comes through check valve, ball valve, which did not get a sticker on it yet, but we will. Comes into our inductor. This is ozone coming this way. It creates a vacuum on our inductor. And this is the discharge side, so we have a little bit of pressure there. Bringing in ozone here. We've got 100 PSI feeding this inductor with roughly 50 liters, 50 liters per minute. Motive air, roughly 15 to 20 liters a minute of ozone coming across, coming in here. We're blending it with 5 SCFM. Actually, probably more like, because this is under like 10 PSI, so this is probably a multiplier about 1.3. This is probably going to be about maybe 7, 6, probably about 6.5, 7 SCFM. So quite a bit of extra air to disperse that ozone. And this is just some tubing we got hooked up for testing. And just testing the differences between 3/8 tubing and 1/2-inch tubing. A huge difference. So that's why we were also saying the importance of having the increased size. We don't want, let the ground be the back pressure. Don't let your tubing be your restriction. So we've got about 30 feet of tubing on each of these, running out the door and going in and going about 300 feet away, so I don't have to smell that nasty ozone. Ozone generator, feed air pressure here, always above 90. So whatever the compressor pressure is what this is. So we're always keeping that happy. Cycle pressure here, should be somewhere around 70, which is really close to it. It's like 68. And there's our tank pressure for our oxygen receiver. And right now we're holding steady at 50 PSI of oxygen. And like I said, we won't, look somewhere at the 20, 21 PSI thereabouts. And you can see I'm showing 17.3. That's just, there's also losses through the tubing, through the hose. You see we're still doing like 16 liters per minute of ozone flow. There is a replaceable particulate filter in there. LED lights, air conditioner controls, lights for front and back room, storage for some paperwork if you want it, auto drain on the air tank, auto drain on the return of the aftercooler. So it's the very, very bottom of the aftercooler. And we're all manifolding into this one big snaky header right here. Right now we're just letting it blow off into the room, so that's why it's kind of messy looking right this second. There's the outlet for the dryer. You see the dryer is powered up. Everything looks good right there where it's supposed to be with green light. Cycling just from one leg to the next, back and forth.